Hello, young math Padawans. It's Mrs. Angel with your lesson for today on adding and subtracting fractions with what we call unlike denominators, meaning they are fractions of different size. How do we add them together? Now, in this diagram here, the first fraction represented is the fraction 3/4. And the second part of this fraction is 5/8. Now, here's the problem. We can't add 3/4 and 5/8 mathematically. In other words, we can't say that that equals 8/12. We can't just add straight across because that doesn't make any sense. The shape and size of the pieces in this diagram are not the same as the shape and size in the second diagram. So right now we cannot total them up. However, we can change one of the diagrams so that they become the same size piece. So to change these fourths into eighths, I have to ask myself, how many eighths are in 3/4? And I can put that actually in the diagram. All I have to do is change the diagram from 4 pieces to 8 pieces. 6/8 are in 3/4. So I can rewrite this expression as 6/8 plus 5 more eighths, 11/8 in total. So if my goal is to change this fraction into eighths, I have to do that with multiplying. Specifically multiplying by what's called a big 1. A big 1 means the same number in the numerator and denominator. So by multiplying 3/4 by 2/2, I've now created an equivalent fraction of 6/8. There are 6/8 in 3/4. I can now add that to 5/8 to get my grand total of 11/8. In the top part of this diagram, I have 2/3. And in the bottom part, I'm trying to add 3/4 to that. Now this one is harder because I can't change thirds into fourths. And I also can't change fourths into thirds. So we have to find some type of common ground, a number that they both multiply into evenly. Wait, don't we have a tool for that? That's right, we have multiplication charts. So one of my fractions is in terms of thirds, the other one in terms of fourths. What I'm going to do here is work my way down the multiplication chart until I find a number they have in common. That's called the least common multiple, meaning that this is the smallest number that both 3 and 4 can be multiplied into. All right, so we have a new goal. I have to change my thirds into 12ths and my fourths into 12ths. How many 12ths are in 2/3? 3 groups of what equals 12? 3 groups of 4. So all I have to do is break each of these pieces into fourths. That's 1 group of 4. That's 2 groups of 4. 3 groups of 4. Let's make sure I count correct.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
So how many 12ths were in 2/3? I count 8 12ths. Let's do the same thing for our fourths. How many 12ths are in 3/4? That would be 4 groups of 3. So I'm going to break up each of these 4 pieces into thirds. That's 1 group of 3, 2 groups of 3, 3 groups of 3, and 4 groups of 3. 12 total. How many 12ths are in 3/4?
1, 2, 3, 4, 5, 6, 7, 8, 9 12ths.
Are in 3/4. Now that these are all 12ths, I can add them together. 8 12ths plus 9 12ths is a total of 17 12ths. Woo, that was a lot of work. Actually, with the expression, the work is easier to do. Again, we already did the hard part. We know that we have to change our expression, both of our fractions, into 12ths. So I'm going to set that up below here. So how do I do that? Well, we have to figure out what big ones to use. How do I turn thirds into 12ths? 3 times what is 12? 3 times 4 is 12. So I'm going to multiply 2/3 by 4/4. That's the same idea as breaking up each third into 4 pieces. How do I change fourths into 12ths? 4 times 3 is 12. So I'm going to multiply my 3/4 by the big one 3/3. That's the same idea as breaking up each fourth into 3 pieces. Now let's simplify. 8/12 plus 9/12 is 17/12. So whether you're using a diagram or an expression, the rule stays the same. You cannot add fractions that are different sizes. They have to be the same size for you to be able to total them up. So let's look at how we can do that in the practice problems below. Starting with the first one, 1/2 plus 1/5. I can't add a half to a fifth. I have to find something they can both be changed into. Let's take a look at our multiplication chart. 2 goes into 10 and 5 goes into 10. That's the least common multiple, meaning the smallest number they both go into. So halves and fifths can both be turned into tenths. So now we have to figure out how many tenths are in 1/2 and how many tenths are in 1/5. So let's figure out our big ones. How do I change halves into tenths? I'm going to multiply by a big one of 5/5. 5 times 1 is 5, and 5 times 2 is 10. So there are 5 tenths in 1/2. How do I change fifths into tenths? You would multiply it by 2, 2 halves. 2 times 1 is 2, and 5 times 2 is 10. So there are 2 tenths in 1/5. 5 tenths plus 2 tenths is a total of 7 tenths. 2/3 plus 5/6. Let's take a look at our multiplication chart. I've got thirds and I've got sixths. What's the first number that you notice that they both divide into? Some of you might say 12, but hold on. There's a number earlier in the multiplication chart. They both divide into 6. That's right, 6 is a multiple of 3, which means we only have to change our thirds into sixths. So that means we only have to figure out how many sixths are in 2/3. We're not going to change the second fraction at all. How do I change thirds into sixths? I'm going to multiply by 2 halves. 3 times 2 is 6. 2 times 2 is 4, so that means 4/6 are in 2/3. 4/6 plus 5/6 is a grand total of 9/6. Over here in number 3, 7/4 plus 1/2. Let's look at our multiplication chart. I have fourths and halves. They both go into 4. That's right. 4 is a multiple of 2, meaning I only have to change one of the fractions in my expression. Don't have to change the first one. We already have fourths. But how many fourths are in 1/2? We're going to multiply this by the big one, 2 halves, because 2 times 2 is 4. In the numerator, 1 times 2 is 2, so there are 2/4 in 1/2. Now we can add. 7/4 plus 2/4 is 9/4 total. 1/12 minus 1/9. Can't subtract 12ths and 9ths. Let's take a look at our multiplication chart. Here's 12 and here's 9. I see 36 in both, and I don't see anything in common above that. So we're looking at making 36th out of both of our fractions. Let's make some big ones. What big one are we going to use to change 12ths into 36ths? You might have to look at that multiplication chart, but 12 times 3 is how we get 36. So a big one of 3/3. 3 times 1 is 3, so 3/36 are in 1/12. And what big one are we going to use for ninths? 9 times 4 is 36, so 4/4. 1 times 4 is 4, so there are 4/36 in 1/9. Now that they're both 36ths, we can subtract. That's going to be negative 1/36 in total. Now that you've seen some examples, it's time for you to try. Go ahead and attempt number 5 and number 6 on your own, and then check back to see how you did. 6 and 8 cannot be subtracted. So I used my multiplication chart and found they can both be changed into 20/4. So I used a big one of 4/4 to make 20/24 for 5/6. And I used a big one of 3/3 to make 3/24 for 1/8. 20/24 minus 3/24 is a total of 17/24. Now number 6, you might have done wrong because you might not have noticed that 10 is the smallest multiple that they both go into, meaning I only had to change one of my fractions. To change fifths into tenths, I used a big one of 2/2. So there are 12/10 in 6/5. Take away the 3/10 from the original expression, and I'm left with a grand total of 9/10. So the most important key from this lesson is that you understand you can only add and subtract fractions that are the same size. So use those multiplication charts to figure out what fraction you can change them into, and then you can feel free to add and subtract as much as you want. That's it for today's lesson. I will see you next time.